All right, guys, are there any questions over the homework assignments before we get started? Any problems y'all want to look at before we start 1-5? For 1-5 or 1-4? 3 through 9 and 11. 3 through 8, you need to find the equation of a line and interpret the slope, so say in words what the slope is telling us. 9 is like the prom venue one, so it's just saying which company charges less per line and how many lines must we have for them to be the same. Number 11, error detection. So you need to explain in words what they did wrong and then fix it. Say what the correct answer should be. All right, guys, so what we're doing today is solving systems of equations in 3 variables. So we're given 3 equations with 3 variables, and we want to find the solution of this here. Now, with any system of equation, we will have an ordered triplet, a solution, x, comma, y, comma, z, that will make all 3 statements true. Now, the solutions we get for this come in one of 3 forms. The first one is that we have exactly one solution. We have a singular point where all 3 equations, because an x, y, z is a plane, cross. They're all going to cross in exactly one point, and that solution, that x, y, z point, will make all 3 statements true. Now, the next type of solution we can have is infinitely many. We have a line, and all the points on this line will make all 3 statements true. And for us here, we're just going to say it is infinitely many. There is a way to actually describe the solution for these points here. But if we get infinitely many, we're just going to say infinitely many. We're not going to go through exactly explaining or writing out the notation for that there. And the last type that we have is no solution. There is no point that all 3 planes cross, or a point or line that will be true for all 3. Because for this first one here, at these 3 intersections, 2 of the planes, 2 of the solutions would have a point that's true. But because it's not true for all 3, it is no solution. For the middle one, both of these intersections, we do have 2 of the planes, 2 of the equations would have a point in common, or multiple points in common, but because not all 3 share a point or line, it's no solution. And this last one, they're all parallel. They don't intersect at all. So again, no solution, nothing in common. This is included in your notes. It is the steps we use for solving. So the first step is to rewrite the linear system in 3 variables as a linear system in 2 variables by using substitution or elimination. We're mainly going to be doing elimination. Step 2, solve the new linear systems for both of its variables. Step 3, substitute the values found in step 2 into one of the original equations and solve for the remaining variables. If you obtain a false equation, if we obtain a false statement at any point in solving the system, it is no solution. As soon as we get a false statement, it's no solution. 0 equals 1. However, if we do not obtain a false statement, but do get an identity, 0 equals 0, a true statement, it's going to be infinitely many. Questions on this so far? If we want to add to this, our first step is we do this. First main step to this is we need to pick a variable to eliminate. And an equation, and an eliminator equation to eliminate it with. Really what we're doing is going from 3 equations with 3 variables to 2 equations with two variables. So our first main step is we want to pick a variable to eliminate out first, an equation to eliminate it with, so that we can take it from 3 equations with 3 variables to 2 equations with 2 variables.
Is it eliminator right there?
Eliminator equation, yes. So we have a variable we want to eliminate, and we're going to get an eliminator equation, an equation we're going to use to eliminate that variable out with. So we're using one of the 3 equations to remove a variable from the other 2. That'll make more sense here in a minute. So the whole goal is this here. We want to go from 3 equations with 3 variables to 2 equations with 2. Our second step, we're going to pick one of the remaining variables and eliminate it. So we're going to, what we have left, so we went from 3 equations with 3 variables to 2 with 2. Now we want to pick one of those 2 remaining variables and eliminate it from both of those. Which means we're going from 2 equations with 2 variables down to 1 equation with 1 variable. And once we get that down to the last one where we have 1 equation with 1 variable, we want to solve for the remaining variable. And as I call it, work backwards. Now, really, all of this here is just what the core concept said. It's just putting it in different words, different ways that we can kind of look at it. Now, the work backwards part is going to make a little more sense as we see it, and actually see what that looks like. Are you ready for the next slide? Okay, you're good. Okay. Okay. So what we're going to look at is this one here. So we're given this equation. We have 3 equations with 3 variables. The first thing we want to do, and the first main step, is we're picking a variable to eliminate out of all 3, to eliminate, and an equation used to eliminate it. Now the question is, do we pick X, Y, or Z? Now the way that I go about picking it is looking at the equation and seeing which one can I turn into the other 2 nicely. Let's look at X first. So we have 4X, 2X, and 6X. When we eliminate or trying to get them to be the same, we want to go up. We do not want to go down. Because to increase in value, we're going to multiply. To decrease in value, we have to divide. Dividing is going to make things not as nice. So it's nicer to go up than it is to go down. So for X, let's look at 2X. What could I multiply 2X by to get 4X? 2. What can I multiply 2X by to get 6X? 3. X is nice because I can easily multiply it to become 4X and 6X. It works out well. Let's look at Y. Always pick the smallest one really to work with because we have 1Y, yes? What can I multiply 1Y to get 2Y? 2. What can I multiply 1y to get 3y? Y works nicely, yes? Let's look at z. Smallest one is 3, yes? What can I multiply 3z by to get 4z? 4/3, but we'd have to multiply and divide. Or we multiply the 3z by 4. We multiply the 4z by 3. They both become 12z. They are the same, but we have to do more steps. Multiplying both equations does work, but if we have variables like the x and y where I can easily multiply them by a single number to get the other two, we're going to go with those. If we have to multiply both equations by a number, we can. I would put it as last resort. If that's the only way we can do it, then we're going to do it that way. So we have a choice between x and y. Those work nicely. Which one do we want to eliminate first? Doesn't matter which. We got to pick one. X. So we're going to eliminate x first. And to do that, we're going to use the middle equation as our eliminator equation. We're using it to remove x from the other two. We picked the middle one because 2x, I can turn it into 4x and 6x nicely. I wouldn't want 4x because 4x, there's not a nice number that gets us to 6x, and we'd have to go down to get back to 2x. Now the two equations that aren't the eliminator equation, we're just going to write back underneath this here. 4x plus 2y plus 3z equals 12. 6x minus y plus 4z equals negative 3. So we're setting these two up so that I can eliminate x out of both. I'm doing this off to the side just so that we can see what we're doing, but we need to get those x's to be the same because we need to be able to remove it. Because currently, we have 2x. For the equation on the left, we don't need it to be 2x, we need it to be 4x. We need the number in front of the x's to be the same. So, as we said already, what did we need to multiply 2x by to get 4x? So, to do this elimination step, we're going to multiply the entire equation by 2.
Do we write this underneath it or to the side?
I'd write it to the side. Because the equation we need is going to be the result of multiplying it by 2. Because our 2 times 2x will be 4x. 2 times negative 3y would be negative 6y. 2 times 5z is 10z. And negative 7 times 2. And we want to put it under that equation on the left. So we're utilizing this equation to remove x from the equation on the left. Now, how we eliminate it is going to be using one of two operations. We're either going to add or subtract to get x to go away. Questions on this here before we start doing the elimination? So now the main question is, how do we decide if we add or subtract? So we're wanting it to become 0. We want it to be eliminated out, yes? What is 4x plus 4x? 8x. Is that what we wanted? No, we want it to be 0, yes? What's 4x minus 4x? 0. So that tells us that we need to subtract all the way through. I focus on the one that we're eliminating to see which one we need to add or subtract, because we need it to be 0. 4x plus 4x did not give us 0. So we're not going to add the two equations. However, 4x minus 4x did give us 0. So we're going to subtract all the way through. The other way we could have done this is if the signs are the same, we subtract. If the signs are opposite, we add to get it to be 0. And so we can actually go about subtracting. 4x minus 4x is indeed 0. The next one we have is 2y minus negative 6y. Negative and negative makes a positive. So 2y plus 6y is, you're good, 8y. Now up to this point, because again, negative minus negatives, subtracting negatives, adding negatives can sometimes be a challenge. And as you've been told multiple times up to this point, those calculators do not do variables. We cannot plug a variable into a calculator. But really, what are we doing here? Because 2y minus negative 6y, we're really looking at what? 2 minus negative 6? 2 minus negative 6? It'll do the coefficients. It will do the numbers for us. We just have to put the variable back in. So we can ask it to do 2 minus negative 6. It tells us it's 8. So it's telling us that 2y minus negative 6y is 8y. You kind of see how we do that there. 3z minus 10z. Can't plug 3z minus 10z in a calculator, but we can ask it to do 3 minus 10. Is negative 7, and we put the z back in. Lastly, we have to do 12 minus negative 14. It would be 26. Because if we did this by hand, the negative and negative would make a positive. So 12 plus 14 is 26. Questions on anything we've done so far? We kind of get what's working. We want to do a few more of it, but we get the process of what we just did, yes? We ready for the next part? We're going to do the exact same thing, but to the other equation. So essentially, we're repeating everything we did, but now we're doing it with our equation with 6x.
So we're good to just like put in the 4x minus 6y that chunk into the other chunk?
Almost. Now we need to figure out what do I need to multiply 2x by to get 6x. I need the x's to go away. Now, if this also had the same x value, it was 4x, then we could just put in the 4x minus 6, or 4x plus 6, or 4x minus 6y plus 10z, because the x's already line up. But here, I need to make it 6x, not 4x. So, we're going back to our eliminator equation. What do we need to multiply 2x by to get 6x? 3. Three times 2x is 6x. That's what we wanted. We're not so much focused on the sign if it was positive, negative. We can take care of that when we add or subtract. We just need the numbers to be the same. 3 times negative 3y. 3 times negative 3 would be negative 9y. 3 times 5z, 3 times 5, plus 15z. Negative 7 times 3 is negative 21. And again, just like with the adding, we could plug in the calculator 3 times negative 3, 3 times 5. We can type those in, it'll tell us. We just have to put the variable back. And just like the other one, we're going to put it right underneath it. We're going to match it up, x to x, y with y, z with z. Questions so far? Now to eliminate it, we need to either add these two equations together or subtract them. 6 plus 6? 12. That's not 0. We want it to be 0, yes? 6 minus 6. So that's telling us we're going to have to subtract all the way through. Now it might seem odd that I'm putting the subtraction sign between each of our terms all the way through. I do it to remind myself that we're subtracting, not adding. I've seen it too many times. I've done it too many times. I wrote it between the first two, between our x's, subtracted the x's, and then immediately followed it up with adding all the rest. We're subtracting all the way through. Now, we did have some where minus negatives turn it into a plus, but the main operation we're doing is subtraction. 6x minus 6x is 0 like we wanted, yes? Next one we have is negative y minus negative 9y. Negative 1 minus negative 9. Negative 1 minus negative 9 is positive 8y. Because really our negative and negative here make a plus. Negative y plus 9y, negative 1 plus 9 would be positive 8. 4z minus 15z. 4 minus 15. Almost. Negative 11. Z. Lastly, we have negative 3 minus negative 21. Positive 18. Negative and negative make a plus, so negative 3 plus 21, 21 minus 3, positive 18. Questions on either one of these here, or questions on how we got here? So it's pretty much the same kind of process we did twice over, yes? We start off with 3 equations with 3 variables. We have now what? 2 equations with 2 variables, yes? The eliminator equation we're not going to use again. We might use it at the end, but that's the whole purpose of the eliminator equation, is to get rid of one of them. That's all we're using it for. Yes, sir? Yes. Now, we need to eliminate one of those 2 out. Because even at this point, we can't solve for 2 variables at the same time. So, just like we picked x, where we figured out which one we can easily turn the number in front of it to be the same, we're going to do the same thing here. So we're going to look at y and z and see which of these 2 variables we can make the number in front of it be the same the nicest. I'd pick y, yes? Because what's the number in front of one of the y's? What's the number in front of the other y? They're already the same, yes? Do I need to do anything to make them equal? If we ever get to a point where 2 or more of them are the same already, might as well use it. Because at this point here, we're just going to line them up. We don't have to do anything to get them to be eliminated. They're already the same. So we just have that set up already. We can go on to the next step and eliminate it. Now the question is, do we need to add or subtract these 2 equations to get y to eliminate? Subtract. The signs are the same, so we subtract. 8 minus 8 is 0. Negative 7 minus negative 11. 7 minus negative 11. 4. Negative and negative make a positive, so 11 minus 7 is indeed 4z. 26 minus 18. So we now have one equation with one variable. We know how to solve those. We can do that nicely, because that's the whole goal. The whole goal of everything we did to this point is to get it down to one equation with one variable. What do we need to do to solve for z? Divide both sides by 4. And really, that's the first part of step 3, solve. We did that part, yes? And now we're getting to the statement I said a while ago, and work backwards, that we would get to and explain and understand how to do that. So any questions on how we got z equals 2? Now we're going to work backwards. We're going to work back up the page. Because again, we can only solve for one variable at a time. We now have what z is. So if I scoot back up the page a little bit, here we have two equations with two variables, yes? Do we know what one of those two values is? Pick one of those two. Left one or right one? Doesn't matter. The right one. What we can do is we can take this equation and plug in z. Because we know z is 2. So 8y minus 11 times 2 equals 18. So by plugging that back in, plugging z back into this, we have now made an equation with one variable. Negative 11 times 2. Negative 22. What can we do next? Add 22, plus 22 to both sides. Because negative 22 plus 22 is 0. Telling us 8y is equal to 40. Lastly, we would divide both sides by 8. Yes. So what is the only thing we don't have the value for? X. So we can keep going up the page. We have several different equations to pick from. We have 5. Because they gave us the 3 starting equations, yes? 4, 5, doesn't matter which. Because we made 2, and we had the original 3. I would not worry about the 2 we made, plugging it into either one of those. I'd pick one of the starting 3. 1, 2, or 3, which one do we want to do?
Well, I got a question.
Yes.
How come we didn't use one of the starting questions to solve for y?
So that's a good question. Why we didn't use one of the starting ones to solve for y? I can show you right here. So at this point, our solution is going to come in this order triplet. We know z is 2, yes? If I use, say, the middle one and plugged in z is 2, it'll tell me that 2x minus 3y plus 5 times 2 equals negative 7. I can only solve for one variable at a time. Because even if we solve this, 5 times 2 is 10. We subtract 10 over. It tells me that 2x minus 3y is equal to negative 17. Now it could be that, say, x is 0, but x could be 2. X could be 3. We don't have any restrictions on what x can be. There's nothing that's set, because I can add 2 things together and get negative 17 in an infinitely number of ways. However, if I am with these 2, I plug 2 in for z, we have 8y minus 11 times 2. I have one variable, I can solve for that nicely. Does that make more sense? Now, we didn't have to do that one. I would not write this because we need the space. But we could say 8y minus 7 times 2 is 26. That'd be minus 14. Add 14. Divide both sides by 8. Y still 5. That's why I said it didn't matter which one we pick. It will still give us the same value. That kind of makes sense how we got there? Yeah, you're welcome. We good? You ready to solve for z? Or not z, x. 1, 2, or 3? Which one do we want to use?
2.
2. 2x minus 3y plus 5z equals -7. Plugging in y and z into this here. Two ways we can go about this. So the first is we can do -3 times 5, which is -15. 5 times 2 is 10. So we get 2x minus 15 plus 10 equals -7, yes? -15 plus 10. 2x minus 5 equals -7. Now, I did say two ways, because now you're kind of curious what the other way is. Is -3 times 5 plus 5 times 2, is there a variable in that part of the expression? Because it's 2 times 5?
Yeah.
That's straight numbers. We can just type that half in, let the calculator do it. It's going to give us -5. Same way to do it either way. Now we actually have to start doing some calculations on our own. First thing we can do is what?
Plus 5 both sides.
Add 5 to both sides. Telling us 2x is equal to -2. Last but not least, we would telling us x is -1. Now the solution, the way we write the solution, is in the ordered pair to x, y, z. So the solution point for this here is -1, 5, 2. Now there's a specific reason we do in an ordered triplet x, y, z. Because that's alphabetical order. X, Y, Z is alphabetically, we do it in alphabetical order. Yes, sir. Yeah. Here or here?
So is this how they kind of solve with the variables?
Yeah, so we solve one at a time, or we narrow it down close enough to where we can't solve for it.
So it's essentially just for percentage.
Yes, versus engineering it. Problems like this here do show up on the ACT from time to time. On the ACT, I would highly suggest you not to do it like this here. What do we know about this point? It's going to make all three equations true. Yes? So, we're good here.
Yeah.
Okay. Because the reason I'm asking is because I'm going to go erase everything. So if answer choice A was -1, 5, 2, I would take the first equation and go 4 times -1 plus 2 times 5 plus 3 times 2. Because if this is a solution, that whole left side should become 12, yes? So I'm going to grab my piece of paper, just so I have the equation. So I grab the calculator and go 4 times -1 plus 2 times 5 plus 3 times 2. And it tells me that that left side is 12. So it says 12 is equal to 12. That is a true statement, so it's telling me that is a solution point to that equation. If it told me that I had, say, -12 equals 12, that's not a solution point. If it doesn't work for one of them, it doesn't matter. It's no solution. It's not a solution. So that works, which means I would then go on to the next one. And make sure it works with this one. Because if I did this by hand, -2 minus 15 would be -17. -17 plus 10 is -7. -7 is indeed equal to -7. It's the solution. because again, that point has to make all three statements true. Okay, you can put it right there. It works for all three, so it is a solution. As soon as one of those points doesn't work for one of the equations, we throw it out. If we tried A and made one of the equations not true, we move to B. If B didn't work, we go to C. If we try C and it doesn't work for one of the three equations, do not try D. We only have 4 choices, yes? If I eliminated A, B, C, my only choice left is, if I only have one option left, we're going to pick it and go. Now, again, last year we've emphasized the fact that for most, pretty much the math section, you need to do a minute a problem, try to keep it around there, yes? Could plugging this in take more than a minute? But are we guaranteed to get this right? At that point, it's worth the extra time to get this right, plug them in, check them, especially to plugging them in. It might take a little bit longer, but plugging them in is going to get me the correct answer. Might as well do it, take the extra time, plug them in, and get it. One more correct answer is always going to help. We really didn't have to actually solve it. We just plugged it in to see which one worked. Questions on this here? Yeah, it's a lot of repetitive steps.
It's not hard, it's just like over and over and over.
We'll do this one here. Now this one here, x, y, and z are all nice choices. Because the first equation we have 1x, 1y, 1z. I can easily turn x into the other two, multiply it by 5 and 4 respectively. Y, I can multiply by 5 to get the middle one. Incidentally, the first and third equation, y is already the same. Or we can do z, multiply it by 5, and multiply it by 3. Which one do we want to eliminate first, x or y or z? Doesn't matter, we can do x. So, and we would want to use the top equation as our eliminator equation. It's got the nice version of x to get it to be the other two. All right. What do we need to multiply x by to get it to be 5x? All right. So we're going to multiply the top equation, our eliminator equation, all by 5. 5 times x is x. 5x. 5 times y is plus 5y. 5 times z is plus 5z. 2 times 5 is add or subtract. 5x minus 5x would indeed be 0, yes? So we'll subtract all the way through, because 5x minus 5x is indeed 0, yes? 5y minus 5y, 0. 5z minus 5z. So the entire left side of that equation became 0. 3 minus 10. Wait a minute. Is that a true statement? That's it.
So as soon as we notice that it's off, it works.
I would still make sure, even if it does look like it's going to completely eliminate out, because we have matching values, add or subtract and make sure. Because there are some, we might see it, where we get, it's going to end up eliminating one, but the others are still going to combine and get the same number. Or get a number. But 0 equals -7 is telling us that those two planes are parallel. They're not going to cross, so there is no solution.
All about points.
If we got 0 equals 0 on this here, we need to check the other side. We need to check the other equation to make sure we don't get a false statement. At that point, it's no solution. We're done anyways.